some applications of z-scores and using the z-scores for percentiles. So question number 1. Uncle Bob says he is taller than 80% of all men. Assuming he actually is in the 80th percentile in height, how could you estimate how tall Uncle Bob is? We're going to assume that men have a mean of 70 and a standard deviation of 5. Okay, so let's think about this. 80th percentile means that the z-score, the z-score is unknown, but when we look it up in our table where it says z-score and probability, we are looking for a probability of 0.8 because the probability is the same as percentile, right? The 3 P's, probability, percentile, proportion. So if we know the percentile is 80th, that's 80%, that's 0.8, we want to look at our table and we want to find where is the probability 0.8. What z-score goes with that? And if you look, the z-score that goes with a probability of 0.8 is 0.85. So Uncle Bob would have a z-score of 0.85. And you may say, I don't know how that helps me. Well, it does. Because, the z-score is value minus the mean over the standard deviation. So if we know the z-score is 0.85 and we're looking for the value, mean is 70, standard deviation is 5. Now we just have to solve this equation. So, same thing on both sides. We multiply both sides by 5. So x minus 70 gives me 4.25. Then we add 70 to both sides, and Uncle Bob would be approximately 74.25 inches in height. So we kind of work backwards from what we normally do. Number 2. What proportion of men would we expect to be between 5'8" and 6'4"? Well, okay, first of all, let's change these to inches. So 5 times 12 is 60 plus 8 is 68 inches. 6 times 12 is 72 plus 4 gives us 76 inches. We know that the mean is 70, the standard deviation is 5. So when we're looking at this here, 68 is less than the mean, 76 is greater than the mean, and we're trying to find this area in between. So first things first, we need z-scores. So value minus mean over standard deviation. -2 over 5 is -4, -0.4. So this z-score is -0.4. 76 minus 70 over 5 is 6 over 5, which is 1.2. So this has a 1.2. Okay, now when you look in at the table, if you look at -0.4 to the left, you get an area of 0.3446. And if you look at, let me get a different color. If you look at the area from 1.2 to the left, you get 0.8849. Well, we don't want all of that area. We only want the stuff in the middle. So if we take this section and cut it out, we'll be good. So if you think about it, if we have all of this, and then we have this, if we subtract them, these will cancel out, and I'm just left with the space in between. So that's what we want to do. We want to take the big number, all of this, 0.8849, and we want to subtract this part of it. And we know that this part of it is 0.3446. So when I subtract those, I am left with the area in between, which is 0.5403. So the proportion of men to be between 5'8" and 6'4", it's roughly 54% of men. Suppose the average U.S. income is $47,000 with a standard deviation of $45,000. So mean, standard deviation. How many standard deviations? And that's another name for z-score, right? Because z-scores tell you how many standard deviations you are from the mean. So what's the z-score for someone who's in the top 1% earning $380,000? So here's our value. So z is the value minus the mean over the standard deviation. And we come up with a z-score of 7.4. Right? Make sure you subtract your numerator first before you divide. If the top 0.1% of the population earns an average of 1.2 million per year, right, chump change, what's the z-score for those earners? Well, here's my value. So z is 1.2 million minus 47,000, which is the mean, divided by the standard deviation of 45,000, and we end up with a z-score of 25.6. And that just seems cray-cray. Next question. Is income in the U.S. normally distributed? Well, let's look at this. Our data says 47,000 is the mean. 45,000 is the standard deviation. So if I go 2,000, my next one is negative 43,000, and the next one is negative minus 45, negative 88,000. This is impossible. So no, our data is not normally distributed, or else these would be positive numbers and we could work with this. So no, this really is not, and you can tell from the z-scores, because really, top 1%, 1% should not have a z-score of 7.4. 1% should have a z-score of like, I don't know, maybe 3 something, right? But 7.4 is so far out there. These z-scores are so crazy and so big that it's just not plausible to be normally distributed. Now this graphic is the distribution of income in the U.S. in 2011. How would you describe this distribution? Well, it looks to be tailed to the right. So we would say that is skewed right. This next example compares two different distributions. We're talking about men and women's heights, and we're going to then compare the heights of men and women in reference to their gender. So who's taller, who's shorter, based off our information. So you have the visual in front of you, and you can see based off the normal distribution curve that the women have a mean of 65 inches while the men have a mean of 70 inches. So we know that the mean falls and splits our normal distribution graph in half. So we're going to use that men have a height of average height of 70 and a standard deviation of 5 inches, while women have an average height of 65 inches and a standard deviation of 3.5 inches. So let's do some problems with this. Number one, again, we're comparing the heights relative to the person's gender. So what percent of men are less than 5 feet tall? So remember, all of our mean and standard deviations are in inches. So the first thing we have to do is take that 5 feet, multiply by 12 to make it inches, and now we have our value. So we can find our z-score, value minus the mean divided by the standard deviation. So negative 10 divided by 5 gives us a z-score of negative 2. Now, if we draw the picture of the standard curve, you know that the z-score of 0 is in the middle, or the mean, and therefore the z-score of negative 2 falls to the left of the mean. If we're trying to find the percent of men that are less than 5 feet tall, we're looking to the left of that z-score. So we go to our z-score table, we find negative 2, and we find the answer of 0.0228, but it wants a percent, change it to a percent, 2.28%. So 2.28% of men are less than 5 feet tall. Let's go to part B. What percent of women are less than 5 feet tall? Well, we already know that 5 feet is 60 inches, so find the z-score for women. Value minus the mean. Don't forget, the mean of a woman's height is 65 inches, and there's standard deviation is 3.5. So I have negative 5 over 3.5, giving me a z-score of negative 1.4. So let's go ahead and draw our normal distribution curve. Again, 0 in the middle. So negative 1.4 is going to fall to the left of the mean. Again, we're finding less, so we go to the left. And percent of women, negative 1.4 is going to give us a 0.0808, change it to a percent. 8.08% of women are less than 5 feet tall. Question number 2. A fathom, which is an Old English measurement, is 6 feet. So what percent of men are more than a fathom tall? Well, 6 feet times 12 gives us 72 inches. So for men, first, z-score. Remember to find percent, proportion, probability, any of our 3 P's, we've got to find a z-score. So value minus the mean over the standard deviation. 2 divided by 5 gives us a z-score of 0.4. When I draw my normal distribution curve with a z-score of 0 in the middle, 0.4 will fall to the right. Now, if I want more than that, I'm looking area to the right. But recall that when you looked at your table with a z-score of 0.4, it's going to give you area to the left of 0.6554. You have to subtract that from 1 minus 0.6554 to find the area to the right, which is 0.3446. Change it to a percent, 34.46% of men are taller than 6 feet. Let's do that same question with women. Finding the z-score, we have 72 minus the mean of 65 divided by the standard deviation of 3.5. And 7 divided by 3.5 is 2. So on our normal distribution curve, right, we now have a z-score of 2, which is quite a bit further to the right than a z-score of 0.4. Again, we're finding area to the right. When you go to the table, area to the left, right, the left of a z-score of 2 is 0.0228 because the table is always to the left. To find the area we want, we will subtract that from 1, and we know that 0.9772, which is 97.72% of women are, oh, that is not right at all. What did I do? I went backwards. Sorry, I looked at the answer. Over here is 0.9772, and over here is 0.0228. I looked at the answer when I needed the other piece. I knew that was wrong because you can tell that this pace is definitely smaller than a half, so it needed to be small. So our final answer is 2.28% on that problem. Sorry about that. Let's go to number 3. Who is taller relative to their own gender? A 5'7" tall woman or a 6 foot tall man? And explain. Okay, so if you're thinking about a z-score, the taller person is going to be further to the right, right? Short people are over here, tall people are over here. So whoever has the bigger z-score will be taller. Okay, so let's look at the woman first. The woman is 5'7". So 5 feet times 12 gives us 60 inches, plus 7 gives me 67 inches. So to find my z-score, value minus mean divided by the standard deviation, I'm going to round to 2 decimal places, and I get a z-score of 0.57 for the woman. Okay, she's taller than the mean, right? We know that. Now let's look at the man. The man is 6 feet. Multiply that by 12 and you get 72 inches. So to find the z-score, 72 minus 70 divided by 5. 2 divided by 5 is 0.4. Since the woman has the bigger z-score, she is taller relative to their own gender. Number 4, who's shorter relative to their own gender? So now when we look at our normal distribution, we're looking at who falls furthest to the left, so who has the smallest z-score. So again, we'll start with the woman. She's 5 foot. So if we multiply that by 12, that gives us 60 inches. So 60 minus 65 divided by 3.5 gives me a z-score of negative 1.4. The man is 5'6". So 5 times 12 gives me 60 inches plus the extra 6. He's 66 inches tall. 66 minus 70 divided by 5 gives me negative 0.8. So when you're looking at who's shorter, well, negative 1.4 is going to be over here. Negative 0.8 is closer to 0. So therefore, once again, as usual, the woman wins. She is shorter. And the last question for this one, how do you stack up? So this is going to be different for everyone, but hey, everybody, I am 5 foot 4 inches, which is 64 inches. So if I want to find my z-score, 64 minus 65 divided by 3.5, my z-score is approximately negative 0.29. So I'm definitely shorter than average because I have a negative z-score, but I'm pretty darn close. So what percentile would I be in? I would have to round to a z-score of negative 0.3 to fit on the chart. That's my z-score. And that z-score would lead me to a 38 percentile. So I am taller than 38% of females, which is kind of depressing, but it is what it is. So that is your video on applications of z-scores.